So on number 5 here, they're asking us to solve the equation. Again, you could solve any quadratic equation using the quadratic formula, but it has to be set equal to 0. So the first thing to do would be to subtract 12 and subtract 12. You'll have x squared minus 12x plus 24 equals 0. Now you're supposed to try to factor, split, and solve, but just by looking at the answers, we know that they're not going to be two nice answers, so it's not factorable. So you might as well jump into the quadratic formula. So right there's the quadratic formula. You have to have that memorized. And how do we use the quadratic formula? You rewrite everything, but with parentheses instead of the A, B's, and C's. There it is. And now we need to plug in our A value, which is 1, our B value, which is negative 12, and our C value, which is 24. So let's plug in our B value, which is negative 12, our B value, which is negative 12, our C value, which is A is 1, and C is 24, and A is 1. So when we work this out, when you go 12 squared, you get 144, and 4 times 1 times 24 is 96, and 2 times 1 is 2. 144, take away 96, 48. So we're going to have 48 inside the root, the plus minus, the 12 on the outside, and the 2 on the bottom. Now, what we need to do now is simplify the square root of 48. The square root of 48 breaks down to 16 times 3. Remember, you want the highest perfect square number. You don't want to use 4 times 12, even though that does work, but it takes more time. 16 is a higher perfect square number that works. When you split it and solve, you have the 4 and the square root of 3 that's left over. So I'm going to rewrite this thing. And, I'm going to rewrite this thing, but instead of 48, I'm going to write down 4 square root of 3. So I have 12 plus or minus 4 square root of 3 over 2. Now, because we have a fraction that has all 3 terms that are divisible by 2, you might as well reduce the whole fraction, all 3 terms, by 2. And if you reduce by 2 here, you'll get 6. Reduce by 2 here, you'll get 2. Reduce by 2 here, you'll get 1. So what's our final answer? It's going to be 6 plus or minus 2 square root of 3. And ladies and gentlemen, this answer right here is up here, B. So B would be the correct answer. So let me delete this stuff to move on to the next one. Okay, moving on to number 6. Ladies and gentlemen, it says express that radical expression in terms of I. Anytime you have the square root of negative 1, that equals I. Okay, so what we want to do here is recognize that the square root of negative 99, we're first going to rewrite the square. Let's not forget about the 7 that's on the outside. That's a regular number 7. But the square root of negative 99, I'm going to rewrite it as negative 1 times 9 times 11. Now, you're probably thinking, why do I want to rewrite it like that? Well, when you break it down, the square root of negative 1 is what? I. The square root of 9 is what? 3. And the square root of 11 cannot be broken down, so it stays the square root of 11. So it's just a question of simplifying here. We said 7 times I times 3 with the square root of 11 at the very end. And I, you just treat it like a variable, like if it were x. What is 7 times I times 3? It's just 21i. 21i, and of course the square root of 11 is at the very end. And there it is, 21i square root of 11. Cool? Moving on. Number 7. Solve the equation. That's an easy one. Anytime you have a quadratic, you could solve with the quadratic formula, but that's not what you're supposed to jump to for your first attempt. If you only have a x squared with no other x's, it's just the x squared, isolate the x squared and then get rid of it by square rooting. So if you subtract 72 and subtract 72, you're going to have 2x squared equals negative 72. And then if you divide by 2 on both sides, you're going to end up with x squared equals negative 36, correct? And how are we going to get rid of the square? You don't want x squared, you just want x. To get rid of the square, you do the opposite of a square, which is a square root, but you do it to both sides. So you're really going to have x equals, don't forget that when you apply a square root within an equation, you need that plus minus that I just wrote right there. And we just said that the negative sign becomes an I, and the square root of 36 becomes a 6. So you really have 6i as your answer right there. So x equals plus or minus 6i, which is option B. Moving on to number 8. Find the zeros of the function. Again, the zeros are the same thing as answers, the same thing as x-intercepts, same thing as solutions. So you're just trying to solve this quadratic equation. How do you solve a quadratic equation? You could use a quadratic formula, factor, split, and solve. You could even complete the square to solve it. Once again, if you look at your answers, you don't have any option that's nice answers like 2 and 3 or negative 4 and 5. These are imaginary numbers. These are complex numbers. So I know that I cannot factor, split, and solve. So I need to jump to the quadratic formula, or we could do completing the square. So normally I would go for the quadratic formula, but we already did an example of that. So I'm going to just show you or review completing the square. So remember, solving this, you have to pretend that the f of x is 0. So you really have x squared minus 4x plus 8 equals 0. So what I'm going to do is use completing the square method. Now the first thing for completing the square method is to make sure that your a value is 1. Is it 1? Yes, it is. Okay. The second thing to do is to make space for your new perfect c value. So I don't want this old c value. I want to subtract it. And I'm going to have my new equation that says x squared minus 4x blank spot equals negative 8. And I'm also going to put a blank spot on this side, guys. That way it'll remind me to add it to both sides, whatever I add. Now here's the process that's called completing the square. What is it? You take half of b and square it. So what's half of negative 4? Negative 2. And if you square negative 2, takes you back to positive 4. Okay? Now you can't just magically add 4 to this side of the equation. It'll get off balance. So you also have to add 4 to this side of the equation. That's why I put that line there to remind me that if I add 4 to the left side, I have to add 4 to the right side to keep the balance. Now the whole purpose of completing the square is to be able to write my quadratic trinomial, this right here, to be able to write it as a binomial squared. And on the right side, I'm going to have a negative 4 because negative 8 plus 4 is negative 4. So how do we get this binomial squared? You could either factor, or you could just simply take the x value that you see up there, you write it down here, and take half of b, and b is negative 4, so half of that is negative 2. So you really have x minus 2 squared equals negative 4. That's what we call completing the square, to be able to write it as a binomial squared. Now, why would I want to write it as a binomial squared? Because I could now apply a square root to both sides of my equation, and I'll get x minus 2 equals, now because I applied a square root on an equation, I'm going to have to put a plus minus right in front of my answer, and we already know that the square root of negative 4 is 2i. That's right. So far my answer is x minus 2 equals plus or minus 2i, but I need to add 2 and add 2. So my answer will be x equals positive 2 plus or minus 2i. And which one is that? It's D. Because you have the positive 2, the plus 2i, and you also have the positive 2 minus 2i. And that's the same thing as this. Positive 2 plus or minus 2i. Looks like a 21. Now, of course, if you do not like completing the square, you could go back and do this whole thing with the quadratic formula, right? You could go back to the original, say that your a value is 1, your b value is negative 4, your c value is 8, and plug it all into the quadratic formula, which is right here. negative b plus or minus square root of b squared minus 4ac divided by 2a. And in reality, it's probably the same amount of work. It's still a lot of work. So you could use the quadratic formula if you feel more comfortable with it. Let's move on. Let me delete this stuff. Moving on to number 9. Here we go. Find the complex conjugate. I love these. It's like free points, right? What is the complex conjugate? Well, first of all, you need to remember that a complex number has to be written in the form a plus bi, where the a is the real part and the bi is the imaginary part. So let me ask you this. Is this guy up here written in that form? No, so you need to rewrite it in that form. So the first thing to do is say, okay, 8 is my a plus 12 is my b with an I at the end. Okay, now that makes sense. Now, the complex conjugate, if you don't remember, all you do is simply change the sign of the imaginary part. You only change the sign of the imaginary part. Only change the sign of the imaginary part. So what are we going to change? Just that plus sign into a minus and you'll be done. So your final answer is 8 minus 12i. And that's it, which is answer A. Moving on to number 10. Solve the inequality. Okay, that is a quadratic equation that we need to solve, but it's an inequality. This was more of the later stuff we did in the semester. We need to solve it. How do we do that? We pretend it's an equation. You find your two answers, but remember, an inequality is an area of answers, so you're going to have to actually test points on a number line. So let's first start solving this by subtracting 20, and I'm going to have x squared plus 7x minus 8. We're going to pretend it's an equal sign and a 0. Now, we could use the quadratic formula to solve this, but what's a quicker method? Factor, split, and solve. So what times what is negative 8 that if I combine together is positive 7? Positive 8 times negative 1. That'll give us negative 8, and if we add it together, it does give us positive 7. Now let's split it. X plus 8 equals 0. And x minus 1 equals 0. Let's solve both of them. X will equal negative 8, and x will equal positive 1. However, this is not an equation, so these aren't the actual answers. They are our critical points. So let me go to a number line here. Let me draw. That's a crooked one, I apologize. But anyways, we have negative 8 on this side. We have positive 1 on this side, and we need to test a value. Pick a point on the inside. 0. Okay, 0 is a good point to pick. 0 is somewhere right there. Let's see if 0 works. Now, what do I mean by let's see if 0 works? I want to take 0 and plug it in for x. Right here, and I want to work it out. 0 squared is 0. 7 times 0 is 0. So what do I have left? I have 12 is less than or equal to 20. Let me write that down. 12 is less than or equal to 20. Is that true? Yes, it is. So what does that tell you about 0? Yes, it works. So if it works, that means that any of these guys on the inside work, which means that my answers are all within the two critical answers. So the answers are together. Now, what does that mean? If the answers are together, that means our inequality is going to be together either like A or like D. It cannot be apart like B or C. If the areas were apart, like this way out here, then yeah, it would be written apart like B or C, but if the areas are together, it has to be written together. So it's either going to be A or D. Now you tell me which ones are going to be. A. Has to be A. You don't even have to think about it, right? Because the other one has a -4 and a -3, which is not correct.